Good morning, everyone. Our objective for the first lab is to show constant velocity motion and model the results using Newton's second law and the momentum principle. To do this, I used a pirogue in a bathtub. Pirogue is the chief watercraft vessel of the Vesu people in the southwestern area of Madagascar. It's a very beautiful vessel. Anyway, I was using a GoPro Hero 3 camera, which was running at 48 frames per second, and pulled the pirogue through the water. Because GoPro cameras have a wide-angle lens, I applied a filter in After Effects to make up for the distortion. After this, I brought the video into Tracker and confirmed that it was running at 47.95 frames per second. Modeling the movement in Python, I set the pirogue's mass to 0.4 kilograms. This mass is an estimation. For the purpose of modeling constant velocity, an estimation is enough, being that Newton's second law dictates that force equals mass times acceleration. Of course, if we derive the formula shown in class, we can see that the change in velocity over the change in time equals the net force over mass, which, if you derive it even further, we create the equation I used for my Python script, that the final velocity equals the initial velocity plus the net force over mass times the change in time. Because we have a constant velocity, the net forces will equal out to 0. That being the case, the final velocity will equal the initial velocity. So the mass is extraneous information, however necessary if we were to use this pirogue for any further experimentation. I've taken the initial position 0, 0, 0 based on the axis that I created in Tracker, and the initial velocity 0.63 is based on the average velocity from time 0 to 1 second and 627 thousandths of a second. I chose to do this because the initial velocity and final velocity should be equal, so I decided to make the average velocity equal out to 0.63 for the Python script. Comparing the experimental position data collected from Tracker and the model position data generated by the Python script, you can see that both lines are very similar and within a few centimeters per second. I believe this discrepancy may have been caused by the selection I had made while generating the information in Tracker. To answer the question of what if the axis were changed, if the axis were flipped, meaning the x-axis were the opposite direction, the forces would still cancel to 0 and the velocity would also flip from positive to negative while the magnitude would stay the same. If this axis were flipped and the pirogue was moving in the opposite direction, the velocity would change towards the negative direction, however the magnitude would still be the same. And to answer whether it is possible to say how many pushes and pulls there are, that is a difficult question. The force of gravity pulling down and the normal force pulling up cancel each other out along the y-axis, and the force of friction perpendicular to the normal force is cancelled out by the force of the string pulling the pirogue through the water. Air resistance is minimal, being that there is no wind in this bathroom. However, if there were wind in this situation, it would also be cancelled out by these strings pull.